We will now look at graphical interpretation and inequalities. So for this example, the function fx and hx are sketched below. Then the question is for which values of x is hx less than 0. So hx here is our straight line, and being less than 0, it means where does the graph lie below the x-axis. So that's all of these values. So now to find out for which values of x, we've got our x-axis over here. So it's all of these values from this point to the left-hand side. That's where the graph lies below the x-axis, or is less than 0. So to answer this question, we first need to find this intercept over here. So if I have my graph as y equals to 4x minus 2, to find the x-intercept, remember I'd set y equal to 0. So if I have 4x minus 2 equals to 0 and solve for x, I have 4x is equal to 2, and then x is equal to 2 over 4, or a half. So here at a half, where to describe the domain where the graph lies below the x-axis, that's where x is less than a half. And notice it says less than 0, so we're going to only say less than a half. And then for which values of x is fx greater than 0. So fx is now our parabola, and once again we use the x-intercept. So for greater than 0, the parabola lies above the x-axis over here. This is where its y values are positive for greater than 0. So once again we need to find the x-intercepts. Now to do that, I'm just going to do it over here. We want to put fx equal to 0. So we say minus 2x squared plus 4x plus 6 equals to 0, and then we solve for x. Divide everything with negative 2 to simplify it, so it's x squared minus 2x minus 3 equals to 0. Factorize it, x minus 3 and x plus 1 equals to 0, so it's at x equals to 3 or x equals to minus 1. So this is where we saw was minus 1 and 3. So now the x values, that's the values that where fx is greater than 0, it's going to be these values over here. So we're going to say from minus 1, so minus 1 is less than or equal to x, and x is less than or equal to 3. So the less than or equal to is because of this sign over here that says greater than or equal to. And then when we work between any two values, if we want to describe anything between two values, we say this value is always less than whatever is inside here, and whatever is inside here is always less than 3. So that's why these signs, when you describe x between two values, these signs will always face in these directions. All right, and then for C, for which values of x is fx less than 0. So now where is my fx less than 0 is going to be over here and here. So that means where it goes this way and this way. So for this part over here is where x is less than minus 1, and see this says less than 0, so we just say less than minus 1, and where x is greater than 3. So that's our answer there. The function of fx and gx are sketched below, for which values of x is gx less than 0. So gx is this function over here, and less than 0 meaning the y values are negative or lies below the graph. So this is all of this, meaning it's going to be from this value over here up until d. So we need to find the x-intercepts, and for g we want to say where gx is equal to 0. So we have x squared minus 6x minus 16 equal to 0. So factorizing that, we saw was x minus 8 and x plus 2 equal to 0. So it's where x is equal to 8 and where x is equal to minus 2. So we have minus 2 over here, we've got 8 over here. So to describe this, if x lies between the two, we say, and it's less than, so we say that minus 2 is less than x and x is less than 8. Alright, and then for which values of fx is fx greater than or equal to 0. So fx lies here. Now, as we can see, it's only it's actually negative for all values except here it's equal to 0. So for b, we have that it's only equal to 0 over here. So that means if we just solve for that, where we have that's equal to 0, so if we say where fx is equal to 0, we substitute in minus x squared plus 8x minus 16 equals to 0. To simplify it, I'm just going to divide everything with a negative. So this becomes minus 8x plus 16 equals to 0. And then to factorize this, we have x minus 4 and x minus 4 equal to 0. So therefore, x is equal to 4. Alright, so this then is 4. So this is where fx is greater than or equal to 0. So it's just where x is equal to 4 is the only place where it's actually equal to 0, but there's no place where it's greater than 0. So the answer is just x equals to 4. So for this question, for which values of x is hx equal to gx. So this can be asked in one of two ways. I can actually also ask, find the coordinates of f and d. That's where the two functions are equal to each other or where the two functions intersect. So now let's say we want to find that. So we say we're going to equal the two functions to each other. So that's just going to be fx equals to hx, and then I set the two functions equal to each other, so minus 2x squared plus 4x plus 6 equals to 4x minus 2, and then I simply solve for x. So this minus 4 comes over, so this is minus 2x squared plus 4x minus 4x, and then plus 6 plus 2 equals to 0. When I take these over, the signs change. So minus 2x squared, add the like terms, this becomes 0, and then this becomes plus 8 equals to 0. If I factorize this, I get, I can actually divide everything with minus 2 first, just to simplify things. So this leaves me with x squared minus 4 equals to 0. So this factorizes difference of squares, x plus 2 and x minus 2 equals to 0. So that's where x is equal to minus 2 or where x is equal to 2. So here, for this coordinate, we have minus 2, and over here we've got 2. So now this is our x values, and if they had said find the coordinates of d and f, we'd simply take these x values, and the easiest is to substitute it into the straight line. We can choose if we want to substitute it into the parabola or the straight line. Best is to go for the easiest one. So that means my value, when I substitute in minus 2 into, we said the straight line, so h, that gives me 4, substitute in minus 2, this gives me minus 8 minus 2, which is equal to negative 10. And then for the other coordinate, h, substitute in 2, this gives me 4, place of x2 minus 2, this gives me 8 minus 2, which is equal to 6. So here we can see that this minus 10 belongs to d, obviously, and we substituted in minus 2. So d's coordinate is then going to be minus 2 minus 10, and f will be 2 and 6. So the function of f of x and g of x is sketched, and for which values of x will g of x equal to f of x. So that means this coordinate and this coordinate. Now here we can see that where x is equal to 0, but we still need to find this one. but we'll just follow the normal procedures. We say f of x, where is f of x equal to g of x, and we substitute in our functions. So minus x squared plus 8x minus 16 is equal to x squared minus 6x minus 16, and then we solve for x. So we take this one over, this is minus, or actually all the terms goes to the left hand side because we want to put this quadratic equation in standard form. So minus x squared, and then plus 8x, this one comes over, becomes plus 6x, and then equals to minus 16, this comes over, becomes plus 16 equals to 0. So here we have minus 2x squared plus 14x equals to 0, and then we substitute, we can factorize out minus 2x, and then we're left with x, that becomes minus 7, equal to 0. So therefore x is equal to 0, or x is equal to 7. So obviously this x value belongs to b, and then this one will be at 7. Now, for which values of x will hx be greater than or equal to gx? Alright, so now hx is the straight line, and where is it greater than or equal to gx? Now, the line is above the parabola over here, so where they intersect here, so it's for all of these values going this way, and it's for all of these values. See here, it's above this, and over here it's also above the parabola, so for all the values going that way. So when we solved, if you given this just like this before the previous question, then you'll have to go about and actually find the coordinates of d and f first, the x values, and then you state the restrictions. But we did it previously, and we saw that the x values was minus 2 and 2. So now, since we know that this is at 2 and this is at negative 2 over here, we know that for all the values, so for the values where h of x lies above g of x is where x is less than or equal to 2, negative 2, or where x is greater than or equal to 2. So this is where x is less than or equal to 2 over here, the line lies above, and where x is greater than or equal to 2, the straight line also lies above the parabola. Okay, so for which values of x is g of x less than f of x? So g of x is this one. So where does it lie above below f of x? Where is it less than? So that's going to be over here. This is where g lies below f. Okay, and then we found the intersects already. If we didn't before, you'd have to do that for this question. So we saw that this is 0 and this is 7. So this whole region over here is where this graph lies below f. So we're going to write it as 0 is less than x is less than 7. Only less than because this question says less than. Now, for which values of x is hx times g of x less than 0? Now, for this question, we're going to say if I have h of x times by g of x, and I want it to be less than or equal to 0, or if I want it to be negative, it means one of these functions needs to be a positive and the other one a negative, or this one needs to be, when this one is negative, this one needs to be positive. This will give me a negative value. So for example, if h of x lies above the x-axis, then g of x needs to lie below it. So where we're going to, the points that we're going to focus on is when do they cross over to positive or negative. Now, let's start with the first condition. Where is h of x positive? H of x is positive from here to here. So is there any point where it's positive and then also at the same time where f of x is negative? So that's actually here. Over here we see that if f of x is positive here and g of x is negative over here, so this is where, now if we solve for this, we previously solved for this, let me just do that again, where f of x is equal to 0, that was where minus 2x squared plus 4x plus 6 equals to 0, so that was x squared minus 2x minus 3 equals to 0, so where x minus 3 and x plus 1 equals to 0, so that was where x is equal to 3 or where x is equal to minus 1, so this is at 3, this is at minus 1. So for everywhere, so for the first condition, my h of x is positive and my g of x is negative where x is greater than or equal to 3. So this is where x is greater than or equal to 3. Now for the other condition, where is my h of x negative and my g of x positive? So that's actually here. See, this is where my graph is negative, but over here the graph is only positive from here. So for this region actually my f of x is positive and over here h of x is negative. So from minus 1 and then where this graph intersects, let's just find out again, h of x was equal to 0 where 4x minus 2 equals to 0. So oh yes, that was at a half. Alright, so here at a half. So from minus 1 to a half. So for this condition it was where minus 1 is less than or equal to x is less than or equal to a half. So putting these two together, basically our final answer will be x greater than or equal to 3 and where minus 1 is less than or equal to x is less than or equal to a half. Alright, so for these two functions, it's asked for which values of x is fx times gx greater than 0. So for greater than 0, if we have fx times by gx, multiplying the two functions being greater than 0, it means it needs to be a positive value when you multiply these two functions together. So for this one, it needs to either be, this one needs to be, if this one's positive, then this one also needs to be positive, because a positive and positive gives you a positive. Or if this one, if fx is negative, gx needs to be negative, because two negatives gives you a positive. Now for the first scenario, we will look at where is both of these graphs, where do both of them lie above the y-axis. And as you can see, there's no place where both of them lie above the x-axis. So this condition doesn't hold. And then if we move on to the next condition, where are both of the functions negative, now the gx crosses the x-axis over here and over here. So for this region, from this A, this x-intercept up until D, both of them lie underneath, except for over here where this graph actually intersect. So it's actually from here, from A to E and from E to D, but not on E. So what we need to do is we need to find where these intersect, and we saw that this one, let's just solve it. Let's just say, where does fx equal to 0? So we can say that where is negative x squared plus 8x minus 16 equal to 0. So that's going to be at, or just simplifying that by dividing everything through with a negative and then factorizing it, we've got x minus 4, x minus 4. So both of the intercepts fall on 4. So this is at 4. And then for the other graph, so this is x equals to 4. For gx equal to 0, we have x squared minus 6x minus 16 equal to 0. And in factorizing that, we can say that's x minus 8 and x plus 2 equal to 0. So x is equal to 8 or x is equal to minus 2. So minus 2 lies over here and 8 lies over here. So we can say that from negative 2 is less than x, and x is less than 4, and where 4 is less than x and x is less than 8. So this first part describes this region over here, second part describes this region over here. And then for b, so now where is hx over gx less than or equal to 0? So in this case we need a negative, so one needs to be plus and the other one minus, or the numerator needs to be minus and the denominator a plus. So these will give us negative values since plus and minus is negative. So for the first condition, if we look at hx, where is hx positive? And there's no place where it's actually positive, but it is equal to 0 over here on 4. And then where's gx less than 0? It's everywhere from a to d. So the only place where this first condition is actually valid is at 4. So this one says that x equals to 4. My hx is actually equal to 0. See this? This inequality says less than or equal to 0. So in this case, equal to 0 also applies, where in this case it's only greater than 0. So the equal to 0 didn't apply. So over here can be positive or equal to 0, and that's just at 4 where it's equal to 0. And then here negative from minus 2 to 8. So the only place where both of those are is at 4. So now for the next condition, so hx, where is hx negative? So hx is negative and equal to 0 actually for all the values of x, so where x is the element of real. And where is our gx positive? So gx is positive over here from there and there. So that means where are both of these conditions met? Over here gx is positive and fx is negative, and over here gx is positive and fx is negative. So it's going to be from these intercepts everything less than negative 2. So that's where x is less than or equal to negative 2, or where x is greater than or equal to 8. But now we need to be careful because this denominator can't be equal to 0, because that would make it undefined. So the only things that we can state here, because we can't make gx 0, so that means this x value of equal to minus 2, these 2 points can't be included in our restriction. So this will only be where x is less than 0 and x is greater than 8. So our values here will be, our final values will be x equal to 4 or x less than minus 2 or x greater than 8.